In this section, we are going to learn about combining differentiation rules to find the derivative of polynomial and rational functions. That's our learning outcome, but it's about combining these rules and going a little further with it. So let's take a look at this. K of x equals 3h of x plus x squared g of x. We want to find k prime of x. So we're going to be using the product rule a couple of times here. There, and I got the bad spot. Product rule here. So let's see. K prime of x is going to be equal to, well, the 3hx maybe isn't product rule. That's that coefficient rule. Okay, whatever. So k prime of x is going to be the 3 times h prime of x plus, now the product rule comes in place where we have that x squared times g of x. So we're going to end up with the derivative with respect to x of x squared times g of x plus x squared times the derivative with respect to g of x. So our k prime of x, sorry about the dogs barking, it's going to be 3h prime of x plus 2x g of x plus x squared g prime of x. And that's it. So they have another example for us. It's kind of interesting. It's this k of x equals f of x times g of x times h of x. We're going to find k prime of x with this. So we don't have to actually do a lot of calculations here. It's just the organization. So the way I do it, I kind of just group things together. So I'm going to kind of group these two together, the f of x and the g of x. So I'll end up with my k prime of x, k of x prime, is going to be, think of this as f of x times g of x. I'm going to say, in fact, let me call this the derivative with respect to x of f of x times g of x. So I'm treating that as one part of the product rule times my h of x plus f of x times g of x times the derivative of h of x, and that derivative is h prime of x. Now we're not finished. We have to go back and look at this other part. So now we have the product rule here again. So that's going to be f prime of x times g of x plus f of x times g prime of x, and all that gets multiplied by our h of x plus our f of x times g of x times h prime of x. Now, this is just from the last part there. Now, if I distribute the h of x into the first portion, we have an f prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. It's kind of interesting, huh? So it's like each one gets a derivative and the others get to be normal in each combination. And that's it. Now we're going to look at combining the quotient rule and the product rule. So in the numerator we have a product, and the denominator, and we have an overall quotient rule. So we have a denominator here to work with. So again, this is just to remind you, the low d high minus high d low all over the square of what's below. So what do we have here? This was an h of x. So we're doing h prime of x is going to be low, which is 3x plus 2 d high. So the derivative with respect to x of 2x cubed k of x minus high, which is 2x cubed k of x, d low, which is going to be, I'll just do d low, or d dx of 3x plus 2, all over 3x plus 2 squared. So let's do a little bit of algebra here. We have a 3x plus 2 times, and some calculus. So this derivative of the product, now I'm going to bring this inside. I'm looking at the derivative with respect to x of 2x cubed times the k of x plus the derivative with respect to x of k of x times 2x cubed minus, I have a 2x cubed k of x times, and the derivative of 3x plus 2 is just 3. All divided by 3x plus 2 squared. So we have a 3x plus 2 times 6x squared times k of x plus k prime of x times 2x cubed minus, looks like a 6x cubed k of x, all divided by 3x plus 2 squared. Okay, now it's all algebra to clean up. So I have this 3x plus 2 times the 6x squared plus kx plus k prime of x times 2x cubed. Oh, I forgot a parenthesis there. Now, that's really a binomial times a binomial. It doesn't look like it, but that's what it is. So I'll just FOIL it out. 3x times 6x cubed, 6x squared is going to be 18x cubed times the k of x. And then we have plus 3x times the k primed of x times 2x cubed. That's going to be 6x to the 4th power. And then I have 2, so plus 12x squared k of x plus 4x cubed. It's 4x cubed k prime of x minus, slide it over here, 6x cubed k of x. So let me just check and see if I can combine anything here. If they have the same, for example, level of derivative or not derivative, and the power of x. So I have that 18x cubed k of x and the minus 6x cubed k of x. Those can be resolved a little bit. Otherwise, I have a 6x to the 4th k prime of x and 12x squared k of x and a 4x cubed k prime of x. So those can't be combined at all. So in the end, we end up with, looks to me like 12x cubed k of x plus 6x to the 4th k prime of x plus 12x squared k of x plus 4x cubed k prime of x. I guess what we could do is clean it up just a little bit more. And if we combine the terms, not combine, but group them by k of x and no k of x, for example, 12x cubed plus 12x squared k of x plus 6x to the 4th plus 4x cubed k prime of x. Could do that, I guess. All over r 3x plus 2 squared. was looking, we could pull a 12x squared out of the first grouping and a 2x cubed out, but we don't end up with the same thing inside, so we'll just leave it there. Okay, that was fun. Let's go forward to another one. I just slid over quickly. Okay. ddx of 3 f of x minus 2 g of x. So that's going to be 3 times f prime of x minus 2 times g prime of x. If you want the long version, that's the short version. I'm trying to think, how can I make that longer? We could look at this as being, or what if we said the derivative with respect to x of 3 times the f of x plus the derivative with respect to x of f of x times 3 minus the derivative with respect to x of 2 times g of x minus, I'm distributing the negative, the derivative with respect to x of g of x times 2. So the first one is 0, and this one is 0. And so what we're left with is this, let's see, 3 times the derivative of f of x, so 3 times f prime of x, minus 2 times g prime of x. Okay, there's the long way if you want the long answer versus a short answer. Okay, moving on. This one we're determining how where a function has a horizontal tangent. So first of all, think of a horizontal tangent. The slope is what? You're right, it's 0, horizontal line. So we're going to take the derivative and set it equal to 0. So our f prime of x is going to be 3x squared minus 14x plus 8. And if we take 3x squared minus 14x plus 8 and set it equal to 0, this factors into 3x times something, x times something. And let's see, 3x minus 2 and x minus 4 work. So 3x minus 2 equals 0, x equals 2/3, and x minus 4 equals 0, x equals 4. So these two places you have a slope of 0, or horizontal tangent. It says the position function of an object on a coordinate axis at time t is given by s of t equals t over t squared plus 1. What is the initial velocity of the object? So what we're after is, what is the velocity times 0? And we're going to take the derivative to find out. So we want to find velocity of t is s prime of t. So that's going to be, remember our low d high minus high d low, all over the square of what's below. So we're going to have low, which is t squared plus 1, d high, which is a 1, minus high, which is a t, d low, which is a 2t, all over t squared plus 1, that's t squared plus 1 squared, all over the square of what's below. So that's going to be t squared plus 1 minus 2t squared all over t squared plus 1 squared. So if we do that subtraction, we end up with t squared minus 2t squared is negative t squared plus 1 over t squared plus 1 squared. So they want to know what it is, and that's our velocity. What's our initial velocity? That's going to be negative of 0 squared plus 1 over 0 squared plus 1 squared. So that's going to give us 1 over 1. So it's 1. Okay, that was fun. Moving on. Find the values of x for which the line tangent to the graph of f of x equals 4x squared minus 3x plus 2 is parallel to y equals 2x plus 3. So our slope here is 2. So we're going to take the derivative. F prime of x is 8x minus 3. And we take 8x minus 3 and set it equal to 2. So we have the 8x minus 3 equals 2. And so we get 8x equals 5, or x equals 5/8. So at x equals 5/8, we'll have a slope that is tangent to the graph that is parallel to y equals 2x plus 3. Okay, here we go for our last one. It says if f of x equals 6x to the 5th plus 6x to the 4th minus 6x to the 3, find f prime of x. There's actually two ways of doing this problem. You could divide everything by x to the 4th and then say that f of x equals 6x plus 6 minus 6x to the negative 1. So our f prime of x would be 6, and derivative of 6 is 0. So the derivative of minus 6x to the negative 1 would be negative 1 times x to the negative 2. So f prime of x would be 6 plus 6 over x squared. But if we go with the other way of doing this problem with the quotient rule, our f prime of x would be, again, low d high, so x to the 4th times derivative of the numerator is going to be 30x to the 4th plus 24x to the 3rd minus 18x squared minus high, which is this 6x to the 5th plus 6x to the 4th minus 6x cubed times the derivative of x to the 4th, which is 4x cubed, all over the square of what's below, so x to the 4th squared. Now our f prime of x would become what? Now we could factor something out of each term. In the first set of terms, I'm going to focus on trying to cancel this x to the 4th power. Maybe I shouldn't, so I can see what actually subtracts out. Maybe we'll do that instead. So we have a 30x to the 8th. Oh, that would cancel. Plus 24x to the 7th minus 18x to the 6th, then minus 24x to the 8th minus 24x to the 7th, then plus 24x to the 6th, all divided by x to the 8th. And there, a lot of things are going to subtract out. 24x to the 7th goes away. I guess that's it. But other things are going to be reduced down. So we have our f prime of x, excuse me, is equal to 30x to the 8th minus 24x to the 8th is 6x to the 8th. Then I have a minus 18x to the 6th plus 24x to the 6th is going to be plus 6x to the 6th all over x to the 8th. So this becomes 6x to the 8th over x to the 8th plus 6x to the 6th over x to the 8th. So it's 6 plus 6 over x squared. Hey, it's the same answer. Not a coincidence. Now, there's one last thing. If you want to go through and read about racetrack safety at a Formula One grandstand, they talk about some applications of that. I'll leave that to you, the student, to go through that, especially if you like Formula One stuff. Talk to you guys later. Bye.